Hello, my dear students. This is Dr. Girish sir. Welcome to the Introduction to Unix and OS course. Let us continue with the Module 2 topics. Agenda of this lecture class is to learn the process basics, the PS command, mechanism of process creation, internal and external command, different states of a process, and zombie process. Note that process is an important piece of the Unix world. Then what is a process? A running program in Unix is called a process. In other words, a process is an instance of program in execution. That is, a program in execution is called a process. Note that a process is said to be born when the program starts executing. After the execution is complete, the process is said to die. Then who is responsible for managing all these processes? The kernel is responsible for managing all these processes. Yes. As you know that files have attributes. Similarly, the processes also have attributes. The two important attributes of a process are the first attribute, the process ID. In short, it is PID. What is a PID? A unique identification number used to refer to the process. So each process created by the kernel is referred by the process ID. The second attribute of a process is the parent PID. In short, it is PPID. Then what is PPID? The number of the process that started this process. So it is the PID of the process that started the new process. Coming to an example of a process, the shell process. As soon as you log into the Unix system, the kernel sets up a new process. So this process represents the login shell, which is either K shell, KSH, Barn shell, SH, Barn again shell, BASH, bash, the C shell. So a shell is simply a process. Second point about the shell process. Every time you issue a command, the Unix operating system starts a new process and suspends the current process, that is the shell, until the new process completes. That is, whenever you try to execute an external command at the shell prompt, the shell acts as the parent process, which in turn creates a new process representing the command you entered. Since every parent has a parent, the ancestry of any process can be traced back to the first process, which is the init process, INIT, init, which is the mother of all the processes, whose PID is equal to 0. Consider an example here. So in this example, we go to the shell prompt and try to execute the cat command to display the contents of the file emp.lst. So in the above command line, the shell acts as the parent process and the cat command acts as the child process. The shell process has spanned a new process called the cat command. Next, the question is, how do you know the PID of the shell process? The PID of the shell is stored in a special variable called $. $$ is a special variable which stores the process ID of the shell. Okay. So how do you display the PID of the shell? So go to the $prompt, type the echo command and $$ as its arguments. We'll use the echo command to display the value of the variable $. So this command prints PID of the current shell. Let me demonstrate this on the online Linux terminal. Now I am at the shell prompt. I want to display the PID of the shell process. Just type the command echo and $$ as its argument. Okay. What is the output? 252. So 252 is the PID of the shell process. Okay. Then next is, what are parent process and child process? Parents and children's. So what is a parent process? A process that creates another process is called a parent process. So a process can have one parent. A process can have only one parent. And what is child process? A process born from a parent process is said to be a child process. Okay. An example. So on the command line, we have combined two commands, cat and grep's, with piping. So in this command line, two processes, namely cat and grep, are spanned or created by the shell process. So here the shell acts as the parent process, which has spanned two processes, which represents the cat command and the grep command. Note that whenever a process creates another process, both parent process and the child process execute concurrently, that is parallelly. We do not have control over each other. And the parent process, sorry, the child process is a duplicate of the parent process. Then there are two different approaches that can be taken by a parent towards its child. That means the parent process has two different approaches for its child. So what is the first approach? The parent process may wait for the child to die so that it can span the next process. So the parent process may wait for the child to terminate, and after the child terminates, the parent process can span another process. So what is second process? Sorry, second approach used by the parent process for its child. That is, the parent process may not wait for the child process to die or terminate at all, and may continue to span other process. So a parent process may not wait for the child to terminate. So without the child terminate, the parent process may span another process. So a parent process may or may not wait for the child to terminate. Okay, but it can continue spanning the next processes. Next, the question is, how do you find out the process status? That is, the processes that is currently running on your system. So this is achieved with the PS command. Stands for process status. So what is PS command? PS command prints out the process status for processes running on your system. So it will list the currently running processes and display information about those processes. In other words, PS command is used to display the attributes of all the processes running on your system. An example. So here PS command is executed without any arguments. So when ps command is executed without any argument, it display all the processes for the current shell. See, just go to the $prompt and type ps and then enter. So what is the output? The output shows header specifying the PID, the process ID, terminal, the time the process has been running, and the command name or the process name. So in this example, there are two processes that are currently running on your system. One is bash and another one is the PS. And see, the PID of bash is 4245, and on which terminal it is executed, PTS/7. This is the terminal file name, and this is the time the process has been running. Okay, and this is the process name. Similarly, another process, that is PS, is running, whose PID is 5314, and it is running on the terminal PTS/7, and this is the time that this process has been running. Okay, let me demonstrate this on the Linux terminal. Let me clear the screen. Just enter ps command without any arguments. Observe the output. So, see, here there are two processes that are currently running in your system, bash and ps, and their respective PID, the process ID. Okay, the next, ps command with options. We use ps command with option to obtain much more information about the process currently running on your system. So this is a table showing the ps command option along with their description. The options are, the first one, -f. As you know that all options starts with -. So when you use this -f option, no, it will display the list of all processes along with PPID, parent process ID. Then the next option, -small e or capital A. This will display all processes including user processes and system processes. So using this option, you can display all the processes including user and system processes. The next one, -u followed by the argument is username. So this will list all the processes of the user USR only. List the process of that particular user only. Then the next option, -a, will list all the processes of the users excluding the system process. -a stands for all. It will list all processes of the users excluding the system process. Then -L stands for long listing. It will list all the processors along with their memory related information. Then -T followed by the terminal as argument. So this option will display the processes running on the terminal TER. If you want to know the process status of the processes on a particular terminal, then you will use this option. Next, the mechanism of process creation. Till now, we know that whenever a program is executed, a new process is created and it will be terminated when its execution is completed. The question is, what if you want to create a process within a program and maybe wanted to schedule a different task for it? Question is, can this be achieved? Answer is yes, this can be achieved. How? Obviously through process creation. That means a process can be created within a program and we want that process to schedule a different task or different program. So how do we do it? There are three distinct processes or phases of a process creation that use three system calls. So there are three phases of a process creation that use three system calls. So question is, what do you mean by system call? System calls are specific routines in the OS kernel directly accessible to the application programs to obtain certain services of the kernel. The system calls are just like function calls that can be executed in the application programs, okay, to perform specific tasks. Okay. So what is the first phase in the process creation? Fork. Fork is a system call. Okay. A process in Unix is created with fork system call, which creates a copy of the process that invokes it. So the fork system call is used to create a new process. Okay. If you look at the bottom, I have given here the prototype of the fork system call or using the fork system call. So this fork system call is defined under the header file unistd.h. Okay, and here it's prototype. Fork is the name of the system call, and this is the return type of the fork system call, and this is the argument that the fork takes, void argument. That means it does not take any argument. Okay. and note that this PID underscore T is equivalent to your integer data type, int. Okay. Note that this fork system call, when executed, okay, return two values. So when the fork system call is executed successfully, it returns two values. Which are those values? A 0 to the child process and the process ID of the child to the parent. Okay, so it returns these two values when the fork system call is executed successfully or on success. Okay, on failure, the fork system call returns a negative value. A negative value is returned by the fork on failure. Okay. The second step in the mechanism of process creation is exec. Exec is also a system call. Child process is said to exec a new program using one of the family of exec system calls. Okay, there is a family of exec system calls. Okay, so this exec system call replaces or used after the fork system call to replace the process memory space with a new program. Okay. So here at the bottom you have the syntax of using one of the family of the exec system call. It is exec lp, execlp. So this is the system call, and note that this is defined under uni std.h header file, and see here the prototype of the execlp system call. So return type is int, the name of the system call execlp, and the arguments it takes. Okay. So it takes the first argument as the name of the program you want to execute, and again a list of arguments that this new process accepts, and each of these argument is a null terminated string, and the last argument must be a null argument. Okay. Then the third phase is the wait. Okay. The wait system call. The parent then executes the wait system call to wait for the child to terminate. So this wait system call suspends the execution of the parent process until the child exit or until the child terminate. Okay. And what is the syntax of the wait system call? So syntax is here. Okay. The system call is defined under these two header files. Okay. And see, return type is PID underscore T, and the name of the system call is wait, and it takes one argument. Okay. And this is return value is the PID of the child process terminated. Okay, and it takes one argument which is a pointer to the location, okay, which receives the PID of the child process which is terminated. To better understand this, that is the mechanism of process creation, let us illustrate with an example. Assume that what happens when you try to execute the ls command. So whenever you try to execute ls command, which will list the contents of the current working directory, a series of things happen to create an environment for the ls command to run. Okay, what are these series of steps? First step is the shell. Okay, the shell perform a fork. The shell process execute the fork system call. Okay, so as you know that this fork system of call creates a new process. Okay, new shell process. Okay, so this PID of this parent shell process is 501, and the PID of the new process, which is the child process, is 748. Okay. Then second step is this new process, which is known as the child process, perform exec. That means it executes the exec system call to execute a new program. So in our example, the new program is ls command. Okay. The process space of the child process is completely replaced by the ls command. Then the third step is the ls command perform its task. That means it will list the files in the current working directory. Meantime, who is the parent process here? The shell process waits for this child process to terminate. That's all in this session. Thank you, all of you.